Hello, my name is Al-Basil Akram Kasrawi Abdul Wahab, and this is Lab 1. So in this lab, we made four circuits. We started with the half-bit adder, then we built an incrementer using the half-bit adder. Then we built full-bit adder using a full adder. So I'll wait, I'm finding the circuit here. Yeah, so this is the full adder, and this is the full-bit adder. And here is the Here's the half-bit adder. So how it works is we have two inputs A and B. When we go A, this is an exclusive OR, so why alone it works. If both of them are on, it doesn't work and the other output is on. So this is the main functionality we use for the incrementer. When we go to when we go to the incrementer here and simulate the experience, we have this input here. This is the increment. So if it's one, you see this is the exclusive OR doesn't work yet because it's only one value. But if you open the incremental, it carries on and goes up, and we can keep doing this until like it reaches the end here, and we can make the final cry value on. Now for the full adder, it's a bit more complicated because we have many more inputs. We have two extra inputs for this one. So we have A, B, C, and it's still an exclusive OR, but it takes three inputs, so A, B, and C. And since exclusive OR kind of works like for odd numbers, it's like it's on if it's an odd number. So we don't use this as much anymore, but we use the AND case here. And so we to check if we have a carry on. Here in the 4-bit adder, we can see this more clearly. Like, we have two inputs, and the way they work is the same way again. So if it actually uses like the AND value, so like as you can see back here, most of the wires in the AND are connected together, but then there's an OR gate over here. And so like if two of the AND gates, or like if one of the AND gates work, then the OR gate will automatically give us a carry out. We can check this here. So if we have the Tn and one value of A, it carries out into the other value. And so if we keep increasing the bits, we can actually get this carry out to work here. We can also keep increasing the B for a similar result. So it's already happened. And yeah, carry out means if we simulate a number like these two are 4 bits, right? So the carry out means if we need a 5-bit number, so like because this is basically adding them, and so f is like 15 and another f is 15. So hold on, okay. And so when this is f and this f, we need to carry out because 15 plus 15 is 30, and in bit notation that would be a higher number. You would need more than 15 values. Uh, So we went to the GTK waves to like simulate to like test if the program is working. But this is the 4-bit adder, and these are my test results. And here is what I used to test them. I used 16 entries. Some had like some checked the same thing, but like I was checking for consistency. So for example, 000, it checks if there's any faults, and no, there's not everything zero. The output is zero. Here, 2914 does get flag overflow and adding two bits of number. So my like the hardest part to comprehend when I was doing this lab is that there are 5 digits, right? And it's one, two, three, 4, 5. And the hardest part was comprehended that each of them was a 4-bit number. So it took me a while to understand that, for example, if this was 2, it meant that it was 2 in binary. And 2 in binary is 1, 0. So that means, and if you check like the test, like the simulation, the simulation file, it would mean this is overflow and this is C out. So this means overflow is on and C out is not. And this was CN, it for like to make things easier, it could only be 0 or 1. Actually, this wasn't CN, this was the sum. This was the output. It could be anything from 0 to F. This didn't matter. This was the CN and it was either 0 or 1. This was A and this was B. So it took me a while to actually understand what each of these values mean. After putting it to the test results, we got a few tests. So here's 29144. It means, do you have an overflow when adding two positive numbers? And what overflow means is it's only applies to signed numbers. So if you're adding anything outside the value of -8 to 7, like outside this range, if we add anything outside, in this case, we would add 1 plus 4 plus 4, which is 9. And since they're all positive numbers, it's outside the range of -7 to 8 because they're only 4 bits, so the signed numbers only have a limited range. And so in this case, when we check the GTK wave, we get that overflow equal 1, and we're actually correct. So thank you for listening to me, and see you in the next time.